Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Out of the Loop by Oscode. And here are the rules. We have Sudoku, where we need to fill every cell with a digit from 1 through 9 such that no digit repeats in any row, column, or 3x3 box. We also have Slitherlink, where we need to draw a loop along the edges of cells. So along the edges here, I guess we should make it reds to match the other ones. So we have to draw a loop along the edges of cells. So it must loop. And the loop does not branch, intersect, nor touch itself. So it doesn't branch. So the loop has to be something along the lines of something like this. This is a valid loop for the Slitherlink. 4 loop segments are already given. The red lines at row 5 between column 8 and column 9. Right? Row 7 between column 1 and 2. Row 9 between column 1 and 2. And row 9 between column 8 and 9. So the Slitherlink is basically just a loop that we have to draw along the edges of the cells, essentially. We have circles, where a digit in a circle indicates how many of its cells surrounding 4 edges are part of the loop. All circles are given, meaning a circled cell containing a 4 must be surrounded by 4 loop segments, while any non-circled cell containing a 4 must be surrounded by either 0, 1, 2, or 3 loop segments. So basically, that means the negative constraint is involved. So basically, if you had a 4, say here, that would mean there are not 4 loop segments surrounding it, right? And in fact, actually, it's going to be, I think it's impossible to have 4. Anyways, that's going to more of the solving. We also have region/loop sum lines, where each light blue line is divided into at least 2 segments, and all segments of a line sum to the same total. This sum may be different for different lines. A line is segmented when crossing a region border, so basically the 3x3 box borders, and or when crossing the loop. So basically, say this loop went like that. Then these 3 digits, or actually that digit would equal the sum of these 2 digits, would equal the sum of these 3 digits, which equal the sum of these 2, which would equal the sum of this 1. Assuming that this Slitherlink does not actually continue to cross this line, essentially. And that's how region loop sumlines work. We also finally have white crop key dots, where white dots separate digits with consecutive values, and the loop may not pass through them. So the loop cannot pass through these white crop key dots. And if, say, this was, for example, a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. Well, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so every region loop sum line is divided into at least 2 segments. Also, we have the circles. The digits in a circle indicates must be 1 through 3, I think. 4 would mean that you have a complete loop around the circle. And we have a single loop here. And the loop does not branch, intersect, nor touch itself. So anytime you would have 4 of these cells, that doesn't work, because then it would have to branch, essentially, to connect to the other Slitherlink cell or edges. So these are all 1 through 3 then. This is 1 through 3, this is 1 through 3. 1 through 3, 1 through 3, 1 through 3, 1 through 3. So we know there's a slither link cutting this into multiple segments. Also, these two digits can never just add up to all 9 of these digits. So that's not going to work. There is no slither link between this one. What else do we know? This is at most a single digit. So that means this cannot, okay, so these cannot be slither link. If this was a slither link, these two digits would have to be the same, which is obviously not true. So it must be at least 2 digits here. This digit must be the sum of this digit has to be the same as that digit. So we know that for certain. So this is the same as that, which means it must be one of these 3 cells here. And this is at least 3. It cannot be broken into 1 digit and then 4, or 1 digit, 2, and 2. So it must be divided into 2 and 3. So we know this cannot be a single digit, so this can't be a slither link either. It must go either here or here, right? It cannot cut across here either. It could cut across any of these lines here, so that's fine. Or it could cut across here. So it's either 2 going up this way, or it's going up this way. We're not sure. Okay. We have 1 digit here. It cannot be the sum of... So we need to cut this line up into a lot of different segments. They all have to be equal, though. So this is this digit. So 45 must be divisible by this digit, whatever it is. It cannot... It has to be 9 then, right? I think this has to be a 9. So if it's not 9, then what segment can the 9 be in here? It can't be in any. So this has to be a 9 here. So this is 9. We have a segment here that is 1 in size, and the rest have to be 2, 2, and 2, right? Because 8 has to be with another digit. Yeah, 8 has to be with 1, 7 has to be with 2, 6 has to be with 3. So we know this is 9. We know there has to be at least 1 segment here that's cut up. We know this has to be cut up at least once. This could add up to... So these two also must be a multiple of 45. It could be 9 here. Cannot be 10 because 45 is not divisible by 10. It could be 9, 15, and I think those are the only possibilities, right? So this could add up to 9, or it could add up to 15. So if it's 9, these are consecutive, and this would have to be 4, 5. If it's 15, it would have to be 7, 8, right? Every other thing is not divisible by 4. 45 is not divisible by them. It has to include 9, obviously. It has to be at least 9, because the 9 digit itself must be in a segment here. So it has to be at least 9, and it can't be, obviously it's less than 17. But 17, the only numbers that divide evenly into 45 are 9 and 15, from 9 through 17. So this is 9 or it's 15 here. Let's see. Can this ever be 3? Maybe? Yeah, it's possible. Hmm. So these are consecutive again. We don't know which one these are. There has to be a slither link cutting this line. That means this must be an even amount. This is odd, obviously. This is even. This has to be, so these two, there cannot be a slither link here. So these two add up to this digit, right? Because they're the same. Because this is a single digit, because for the segment, these two cannot be the same single digit, so therefore they must be part of another segment. This is even then. These are even. This must be odd, so this has to be an even here. This is 2, 4, 6, or 8 here, right? Because to add up to an odd digit, these are all even. These are even, because these two add up to this. These two must add up to this, or these two must add up to this. We're not sure which. Again, it can't be divided into 3, because then they would be the same digit, which is not allowed in the row. This adds up to an odd digit because it's consecutive. So to add up to 45, which is an odd number, these are even, this is odd, we need another even here. So that's that amount. We don't know if this is even or odd. Okay, so to add up to, there's 6, okay, this is the same as this digit. So that's another thing we have there. So again, it cannot break here, and it cannot break here, because then these two single digits would basically add up to whatever, would basically be the same digit as these, which is not allowed. Okay. So from here, this line has to either go here or here. We're not sure which. And if it goes this way, it must go there. Okay, that seems fine. You have 5 digits here, which must add up to 2 times a single digit. 5 unique digits adding up to 2 unique digits. Sorry, a digit times 2. Because it cannot, again, you can't have single digits here. So you can't have 3 segments here. This has to be 2 segments specifically. This is 2 segments. Well, 5 unique digits at minimum add up to 15. 15 is greater than every digit doubled except for 8 or 9. So these have to be an 8-9 pair. So one of these is 8, one of these is 9. And these must be the sum of, if it's 8, it's 1, 2, 3, 4, and 6. If it's 9, what can it be? Well, okay, one thing we can do is we can get, we have an 8-9-8-9 pair in, well, okay, so what is this? To add up to 8 or 9, it has to be, if it's 8, it's 5, 6, or 7. If it's 9, it's 6, 7, or 8. These we're not sure about. This cannot be. What can these be, actually, is the question. If it's 8, it has to be 1, 2, 3, 4, 6 here. Right? To add up to 8 times 2, which is 16. If it's 1, 2, 3, 4, 6, that means this is 8. These would have to be 5, 7, and 9. So either this is 5, 7, and 9, or this is 5, 7, and 9. We're not sure. Either way, this cannot contain 5, 7, or 9 here. So it's 1, 2, 3, 4, 6, or 8, right? If it's 9 here, that means these add up to 18. Okay, so this can't be 8 because of the 1, 8 pair in the 8, 9 pair in the row. Red also has to be one of these 3. These are consecutive. That's interesting. Again, this must be divided into 9s. So obviously this can't be a 9. So this can never have a slither-rink because it can't be one single digit. This can't be a single digit, so this must be a slither-rink. Actually, we know this must be divided here. And it cannot be divided here because this can't be 9 by itself. So this must go here. These two can't be 9 by itself. Where is the 9 possible to be by itself? It could potentially be here, here. It cannot be here by itself. So either it's here. So the 9 cannot be here because that would force this to be 9. Sorry, that would be a single digit, and that would be 9 then. So 9 could be here, which you have 2 adding up to 9, 2 adding up to 9, 2 adding up to 9, 2 adding up to 9. 9 could also be here, because these two could be add up to 9, these two, and these two. Where else can it be? It can also be here. So 9 could be any of those. 9 cannot be here, but it could be any of these 6, right? Because this could still add up to 15. What happens if it adds up to 9? That's actually interesting. 9 cannot be here. So these two add up to, so it's 1 through 7. The rest of row 6 is 1 through 7. Okay. One of these is 5, 7, 9. That means 5 and 7 have to be in the 5 digits adding up to 9, right? If this is 8, that forces this to be 1, 2, 3, 4, 6 to add up to double of 8, right? And so this is 5, 7, 9, which means 5, 7, 9 cannot be here. 5, 7, 9 would have to 9 would have to be here. 5 and 7 would have to be here. So to add up to 18, which is 9 doubled, you have 5 and 7 already, which is 12, and the other 3 digits must be 1, 2, and 3. That leaves this as 4, 6, 8. So this is 4, 6, 8, 5, 7, 9 as possibilities, and this is 4, 6, 8, 5, 7, 9. which eliminates 4, 6, and 8 also in the rest of this box. That's interesting. Huh. That means the rest of this box cannot be 1 through 3. So it has to be 4 through 9 here. This cannot be an 8-9 pair because of the 8-9 in the row. The rest of the row, 7 has to be 1 through 7. Okay. Okay, so 1, 2, 3, 4, 6 adds up to 8. So it must be 1, 3, 4, and 2 and 6. For the 9, we have to have 2 and 7 together and 1, 3, 5. Because again, 5, 7, and 9 cannot be in the non-connecting cells here. This cannot just be 1, 2, and 3 all together to add up to this segment. You could divide this into just to one segment here. This cannot be 9. So 9 has to be one of these two. Okay. Oh, this is 4, 5, 6, or 7. This then must be the same. So this is... Oh. Wait, can they be... Oh. This is the same digit as this one, right? Because of how region sum lines work. Where is it in column 5 then? Can't be here because it can't be... We already have that in the box. Can't be here. It must be one of these cells. So one of these is cut up. This cannot be cut up by itself. So this cannot be cut, but this has to be a slithering, which means this is the yellow cell, which is 4, 5, 6, or 7. So this adds up to at most 7. 9 has to be one of these two digits here, which means 9 cannot be here. So this must be a 9 here, right? Because this adds up to 4, 5, 6, or 7. We're not sure which. This is 4, 5, 6, or 7. 8 could be along here. 8 could be somewhere here too. We're not sure which. Can this be 9 by itself? If this is 9, that would force this to be 4, 5. I don't think so, right? 9, this would have to be 4, 5. So the rest would have to add up to 18. Would have to be 18 specifically. So 9 plus 4, 5. Plus 9. Right, because this would have to add up to 9 either here or here. So this would be 36, but then this would be 9, and that's not allowed. So it cannot, so this cannot have a slither link here. Okay, whoops. This cannot be a slither link here. It either breaks here, here. This is at least 18. Can it be these 4 digits? What's the minimum of these 4 digits? It'd be 9 plus 4, 5, 6. So I don't think that can work. So 9 plus 4, 5, and 6 adds up to 15 plus 9 is 24, so this would also be 24, which adds up to 48 for less than a full box of the digits 1 through 9, which is not allowed, which doesn't work because 45 is the minimum, is the exact amount you have to add up to. Therefore, it could be just 2. It could be 3 possibly. And you could have 3 with these 5. So this is 9, and this already adds up to 6. Oh, that's interesting. So if it's 2 here and 2 here, and then this is 4, what could that be? Hmm. Let's see. It obviously cannot be 945. It could be 94. Okay. If you have 3 and these 5 adding up to the same digit. That's interesting, actually. So then the line would have to be basically something like this, if that's the case. Because it could not cut up anything else. So it'd have to go like that. I mean, that seems it's possible, right? So these two add up to an even digit, which makes this an odd digit. So this would be 5 or 7 here. If it's 5, that means these add up to 20. So it'd be 4, 7. It could not be 5, 6. So it'd be 4, 7 here, which would make this 1, 2, 3, 6, and 8. That seems possible. If it's 7 here, then these add up to 19, right? So it would have to be 9, 4, and 6. Interesting. But we're not guaranteed that it breaks up this way. It could be broken up to 2, 2, and 4. So it could be divided by 3. So it's divided into 2. It's either, okay, well, we know this cannot be by itself. It could be 3 digits and then 5. Or it could be 2. If it's 2, 2, and 4, that is possible. Or 2, 3, and 3 might be possible also. The minimum, if this is 3 segments, would be 13 plus 13 plus 13. Right, so you could have 1, 2, 3, 7, 4, 9, 5, 8, and this is 6. Or could you have 9, 4? So either way, 4 I think has to be one of these two, right? If it's divided into 2, this has to be 5 or 7 to force this to be an even number here. And this would have to be, if this is 5, this is 9, 4, 7 to add up to 20, because 5 is here, so you can't have 5 and 6 here. If this is 7, this has to be 9, 4, and 6 to add up to 19. So either way, we have a slither link either going this way or going this way into here. It cannot go through the other way because that would make this segment a single digit, which is not possible to add up to 13 at minimum. So this cannot go the other way out. It therefore has to go through here, guaranteed. And then it goes through one of these two links here. So again, okay, so what are the possibilities? The possibilities would be this is 5. Oops. This is 5. This has to be a 4, 7, 9 to add up to 20. And this is a 6, 8 pair. If this is 7, this has to be 4 and 6 adding up to 19. And this must be 5 and 8 here. If it's 3 segments here, this must be 6. So each of these must add up to 13. So this must be 9 and 4. So either way, 4 has to be one of these two, which means this can't be 4 and that can't be 4. This can't be 4 either. This can't be 4. It has to be 5, 6, or 7. If this is 6, this has to be 4 and 9. So then this would guarantee have to be 1 and 5. Okay, that seems reasonable. 4 and 9. It could be 5 and 8. 1, 2, 3, 7 in that case. Or you could divide along 3 here. Can you ever have 4? No, because this is at most 11 here. So if you could have 9, 4 here, you would not have 8 here. It would be 8, 2, and 3 here. This would be 1. So you'd have 1, 5, and 7. This could be 1, 5, 7 here to add up to 13. And that could work. So this is kind of, yeah. Not sure. One thing we know is 8 has to be one of these 3 digits here. Because 8 cannot add up to 5, 6, or 7. It cannot be 5, 6, or 7, obviously. Interesting. One of these is 5, 6, or 7. This is 5, 6, or 7. Does one of these have to be 5, 6, or 7? Yes. Right? To add up to 8 or 9, it's either 1, 7, 2, 6, or 3, 5, or 2, 7, 3, 6, or 4, 5. So this cannot be 5 or this cannot be 5, 6, or 7 here. This can't be 5, 6, or 7 because we need a 5, 6, or 7 here. Okay. What else does that tell us? I'm not really sure, but this can't be 4 because one of these two is 4. Okay. Interesting. So if this is 7, 8, that means this is 15, right? This then becomes 9, which makes this 9. This is 8 and 8. This cannot be 1, 7, cannot be 1, 8, cannot be 2, 7, so it must be 3 and 6 here. That's interesting. So this can't be 6 or 8. This is 2 or 4. This 3 would signify, and that can't work. This 3 would signify this has to have 3 slither links around it. Obviously, this one can't be. But then the problem is this branches. So that does not work. Right, so this can never be 3 here. This can't be 2 and 5, so this has to be 6 or 7. So this cannot be 7 and 8. This has to be a 4-5 pair, which eliminates 4 and 5 in the rest of the row and the box. This is 4 and 5. Then for the 9 must be by itself. It cannot be here. So similarly, the 9 can be here. That means these are all 2 cell segments here, except for the 9. It cannot be, so 9 cannot be here. 9 has to be, again, one of these 3, I believe. Cannot be here, because then that would force this to be a segment by itself, which would be 9, so they would have repeats. Obviously, 9 can't be any of these. This can't be 9, because these 3 digits would have to add up to 9, and therefore you would have to have another single digit here, which doesn't work. And this can't be 9, because these 3 would then have to add up to 9, or you'd have to have another single digit, which would obviously not work. So 9's one of these 3. That means this cannot have a slither link. Slither link could be here. This could be slither link here too. That's it, actually. That's all we know. These are consecutive. So this digit, 4 and 5. What else do we have? This. 8 obviously has to be one of these 2. So if this is 5, this becomes 4, 7. If this is 7, it becomes 4, 6. So we're not guaranteed what these are. Therefore, this could be 4, 9, but this could be 5, 7 with 1, and this is 6. These digits can be obviously 1 through 8. But they cannot add up to 9. That's interesting. So this cannot be 4 and 5, but it could be 4 or 5 with 3 or 6. Okay, that's not helpful. This obviously adds up to 9, so 1 through 8. This adds up to 9, 1 through 8 here. Oh, this has to be a segment here, guaranteed. So this is a segment guaranteed. This is a segment guaranteed. We know that for certain. We don't know any of the rest, though. Um, hmm. Okay. These are consecutive, and this can't be 9. So this is 3 through 8 to be consecutive with this. Can this be 1, 2, 3, 5, 7? Yes. 4, 6, and 8 are. Could be here. Um. That's interesting. If this is 8, this has to be 2 or 6. So this cannot be a 2, 6 pair adding up. Therefore, this would be 1, 3, 4 this way. This would have to be a 2, 6 pair. So if this is 2 and 6, that would necessarily have to make this 8, but then that would eliminate all possibilities for that cell. So this can never be 6. This has to be a 7. So it's either 1 with 7 or 2 with 7 here. Therefore, this cannot be 7 here. There's no 7 here or here. 7 cannot be here, which means 7 can't be here, 7 can't be here. This can't be 7, so this cannot have a 1 here. Because 1 and 6 would add up to add up to 7 at most. Okay. So this is 5 or 6. One of these is 5 or 6. And that's all we know. This is 7. What are the possibilities here? Can this ever be 8? If this is 8, that's 9, which forces this to be 2, 7. Then these would be divided into 1, 3, and 6, which is not allowed. So I think the answer is no, this cannot be 8. So again, if we try to make this 8, this becomes 9. This adds up to 9, so it's 2 and 7. That leaves the remaining digits as 1, 3, and 6, and they can't add up to each other. So this cannot be 8. This is 2 or 6 here. So if this is 8, this becomes 2 and 6. And this is 1, obviously. So this would be 1, 3, 4 here. If this is 9, this cannot be 2, 7. It would have to be 1, 3, 5. Okay, so 8 can't ever be here. So this can't be 8, which means this can't be 9. This can't be 7 and 8 adding up, so this has to be 3, 4, 5, or 6 here. Cannot be 4 and 5. One of these, though, has to be 4 or 5. So since this is 4, 5, and this is 4, 5, that eliminates 4 and 5 in the rest of column 3. So it must contain 3 with 4 or 5, or 6 with 5 or 4. Therefore, this set cannot adds up to 9. Cannot be 4 and 5 because that would eliminate all possibilities here. Can't be 2, 7 because the 7 is in the column. Can't be 3 and 6 because that would force both of these to be 4, 5, which would eliminate all possibilities for that cell. So this has to be 1, 8, and this cannot be 1. So this is either 2 here and 6 here, adding up to 8. So this would be 2 and 6, or this is a 3, 5 pair with this being 1. Because if this is 8, this cannot be 2, 6 here, so it would be 2, 6 here. If it's 9, this can't contain 2 and 7, so this must be 2 and 7. Okay, so the possibilities then are this is 2, 6, or this is 3, 5, 1. Well, okay, so, sorry. If this is 3, 5, 1, okay, so this 1, 8 pair eliminates 1 and 8 in the rest of column box 1 and column 3. So this cannot be 1. This has to be 2 or 3. This cannot be a 1, 8 pair because that would eliminate all possibilities for 1 and 8 here. So this is 2, 7, 3, 6, or 4, 5. If this is 8, this is 2, 6. So this would have to be 5 in that instance. So again, if this is 8, this cannot be 2, 6. This would have to be 2, 6. This would be 1, 3, and 4. This would be 1. This would be 2, 6. So this would have to be 5, which would force this to be 4. You'd have a 9 here. And that would not work, I don't think, right? If this is 8, this is 1, 7. I guess it'd be 9, 3, and 6 here, which would make this 2. I think maybe that does work. Okay, so that does work. If this is 8, this becomes 9, 3, 6, because it can't be 1, 8, 2, 7, or 4, 5. So that does work in that instance. If this is 9, this becomes 2, 7, so this is 6. 9, 2, 7, 6, 4, 5. You'd have 1, 3, and 8, which don't add up together. So this must be 8 then. This has to be 8. This is 8. This becomes 2 and 6, which forces this to be 5, 4, 5. This is 1 and 7. This is 3, 6, and 9. This has 1 slither ink around it. This is 2. That means this is 2, 6. This can't be 1. This becomes 1, 3, and 4. But this can't be 1. This has to be 7, 9 pair, which eliminates 5, 7, and 9 in the rest of this row. 8 eliminates 8 here, so this is 9, which makes this 9. This cannot be 1 here. So to add up to 9, it's either 3, 6, or 4, 5 here. And 2 has to be one of these 2 digits. This can't be 3, 6, or 9. To add up to 5, it would have to be 1, 4. To add up to 6, it would be 1, 5. So either way, this is 1. One of these is 5. This cannot be 1 here. We have 1, 3, 4 here. This is 4, 6, 8. This cannot be 6. We have 2 and 7 added together. So 8 cannot be this one. 8 is one of these 2. It's 1 and 8. This cannot be 6. This only has 1 slither link next to it. This must be 3 or 9. Because of what's left in column 3. This has to be 1, 2, 3, 5, and 7. This can't be. This is either 1, 3, or 5, or it's 7 because this is 2, 7 if that were the case. These cannot be 6. So if we try to have this being 5 and this being essentially divided into 2 segments, the problem is that doesn't work because these segments have to add a 20, so this would be 4, 7, and 6, 8 would have to be here with 1, 2, or 3. But 6 being here eliminates 6 from being here. So this must be a 6. This is 6. This is 6. This has to be 5. This can't be 3 anymore because of the 3, 6, 9 triplet in the row. This can't be 9, which leaves where's 9 in box or column 4? It has to be here. That leaves these digits as 3, 6, 7, 8. Well, to be consecutive, this has to be 7 with 6 or 8. So the rest of the row cannot be 7. This can't be 6 because of the 6 in the box and the column. This can't be 6, obviously. This can't be 6. This must be 13. So this is 4, which means this is region. It could be 5, 8 or 5, 7, 1. We are not sure. This can't be 2. This can't be 2. This can't be 4, obviously. So this cannot be 2 and 7 here to add up to 9. So this must be 7 and 2, which means this slither link is here. There is nothing here. There's no slither link here. This cannot be 2 or 7 here. This 5 being one of these two means this can't be 5 here. So this becomes a 7, 8 pair, which eliminates this 7 eliminates 7 here. So this is 5. That makes this a 1, 3, 1, 3 pair. That's fine. This cannot be a 3, 6 pair. So it's either 2, 7 or 4, 5. Cannot be 2, 7 here. So this is 4, 5. This 4, 5 pair eliminates 4 and 5 in the rest of the box. And this 4, 5 is only consecutive with 3 or 6 remaining. So this is either 3, 6, or 9. This cannot be 3, 6 because it's the 3, 6 pair has to be one of these two. It has to be either this one or this one. We're not sure which. In column 9, one of these is 1, 2, and this is 1, 2. So that eliminates 1 and 2 in the rest of the column. This can't be 1. This is 3. This can't be 1 or 3. So it's 5. That's 1. So this has 3 slither links around it. So it has to, oops, it has to go this way. So that means it must connect all the way to here. This one has to go that way. That doesn't work. Unless the slither link doesn't... in which case I have to redo the 4, right? Because otherwise this has to go here, and it basically forms a loop there, and that would branch then. Okay, that's problematic. Oh, no. Okay, never mind. It could go this way. In fact, it has to go that way. Okay, right. So then this is 5, this is 1. That still works. So it has to go this way. Which means, yeah, so this one has to go here. This one has to go here. This cannot be 2 because then there would be a circle around it. So it must go this way then. This cannot go that way, so it must continue that way. So this is not a slither link, and this is not a slither link, so this is 1 or 2 here. Right? Because it can't branch, can't branch. This cannot be just 2, and it would have 2 if that's the case. This has 3, so that's good. This cannot continue down here. So this is not a slither link. This can't be, this can't be. This can't be because that would be branching. This is 1 or 2. So if it goes this way, if the slither link goes this way, that would force this to be 3 because it can't go down to the other, because that would be branching. So this cannot be a slither link. So then it must go this way then. Okay. This digit cannot be 9. This digit cannot be 9. So now we have a 3-6 pair. This has to be a 9. So this is a 9, which means these aren't blue. That eliminates 9 here, so this is 3. This is 3. This has to be 9 because this can't be 9. This is 3 and 6. That forces this to be 2 and 7. This is a 4-5 pair, which eliminates 4 and 5 in the rest of the column. This can't be 4, therefore this must be 4 here. We have a 1-8 pair here. We have to have a boundary here, a boundary here, and a boundary here. Therefore, there's a boundary here and a boundary here. Let's see. This 3-6 pair eliminates 3 and 6 in the rest of the row. So this can't be 3 or 6. Where is the 3 then? This 2-7 pair eliminates 2 and 7 here. That makes this a 1-7, 1-8 pair, which means this can't be 1. This is 2. This has to have 2 boundary, or it's 2 slither link boundaries, so it must be here, and then it must go up, because it cannot go down, because that would be 3 then. Obviously, this can't be a boundary then. This becomes a 2-7 pair in this segment, so this must be 7, which makes this 2. This can't be 7 or 8. This must be 6, which makes this 7. This can't be 6. This can't be 3 and 6 added together because of the 6 in the box. So this is a 4-5 pair, which eliminates 4 and 5 in the rest of column 7 and 8 because of the 4-5 pair. So this can't be 4. This must be a 4 here. And this can't be 4 here. So this is a 2-3 pair here. Okay. We have a 1-8 pair in row 2, which eliminates 1 and 8 in the rest of the row. So this is 2. That means it has 2 slither link borders. We don't know where. This obviously can't be. This can't be. This can't be. Obviously that can't be, and that can't be. We have to go here. Okay, we have a cannot have a border here. We do have to have a border here. This slither link cannot go here or here, so it must go here. We don't know about this. Could go either of these directions. Either it's these 3 cells adding up to 13. It cannot be 2. So this cannot be a border here. So this red does have to, this red slither link does have to go this way. And it could be either here or here. So one of these two is a slither link around this cell. So this cannot be a slither link either. So it must escape from either this way or this way. Huh. This has two slither links around it. We don't know which one. This has one. This 3 means this can't be 3. This is 1, which makes this 3. This cannot just have a single slither link around it. But it could have the slither link go up this way, so we don't know what necessarily. This 3 already does not have 3 slither links around it. This only has 1 slither link around it, so this is 1, which means this cannot be 1. So you can't have 5, 7, and 1 adding up to 13 here. This must be 5 and 8, which makes this 7. So the border must be here, which means none of these can be slither linked. So this must go this way. What else do we know? We have a 3, 6, 8 triplet in column 7, which eliminates 3, 6, 8 in the rest of the column, so this must be a 1. That leaves this as 3 or 8. That's fine. We have 2 here. That's fine. Where can this line, this segment go? Or this slither link go? It cannot go here because then it would branch. So it must go that way. So this exit out this way. This cannot go that way because then that would branch. So it cannot go these. This has to go then here. That's 2, which means this cannot be a slither link. This can't go this way. It must go this way then. Oops. This way. Okay, that's fine. Don't know how these slither links go. We need one here and one here. We're not sure which. And it cannot go out the other way because then this would be separated by themselves. So only one goes in here and then one goes out one of these 2 ways here. This must be divided into 2 segments at least. Actually, I think it has to be 2 segments. It can't be 3 segments. Because if it's 3 segments, that means there's 2 cells here, which are the same digit, which is not allowed in the box. Also, what are the possible digits remaining? Oh, this 2 eliminates 2 here, so this is 3, which makes this 2. That 3 eliminates 3 here, so that's 8, which makes this 3, which makes that 8. The rest of column 6 is 4 or 5, I believe. And this cannot be 5, so this is 4 and this is 5. That eliminates 5 here, so this is 4, this is 5. That means this cannot be 8. It's either 3 or it's 7, right? The 5 and 2 add up to 7. The 2 and 3 would add up to 8, 5. 2 cannot be any of these. Where is the 2? Okay, this 2 eliminates 2 here, so this is 3, this is 2. This cannot have 3 slither links around it, so this is not a slither link. Therefore, this has to go up. And it can't go anywhere else, it has to go up again. This has to go that way. If we tried going up here, the problem is this wouldn't loop, right? This would basically be by itself. And it would be like a loop by itself. So this cannot go up here as a slither link. So it must connect this way. And this cannot go anywhere except here now. So this must connect here. Now we know this is the end for 1. So if it tried going this way up, the problem is this would have one slither link and you could not go back here to form a loop. So this must go this way to not have a circle around it. So this is 1. This cannot be a slither link then because that would branch. This cannot be slither link, so this must be a slither link here to make it 1. This cannot go this way. Cannot go left because then this cell would have 2 slither link edges. So this is not possible here. If it goes that way, that would close the loop, so that's not possible. So it has to go up. This could go left. Sorry, it could go right or it could go up. We don't know which. But if it goes up, these don't connect, and that would force this to have a 2, which is not allowed. So this cannot go up. Then for the slither link, it must go right. Okay. This is 1. This goes here, so it cannot, these, again, it cannot go down because it can't form a loop that way. It must go there. It could connect here, that's fine. This 3-6 pair eliminates 3 for that from the row, so this is 7, which means the slither link breaks it this way, which means this cannot be a slither link. Remaining digits in row 1 are 1 and 8. This can't be 1, so this must be an 8 here, which makes this 1. The remaining digits in box 2 are 3 and 4. This can't be 3 because of the 3-6 pair, so this is 4, this is 3. Therefore, these are not, well, can't be there. We have to have a slither link here to break this into even cells, so that's 1 and 8. This could connect this way. What is the remaining digit here? It's 7. This has a single slither link. Okay, this slither link cannot go this way because it goes to a dead end here, right? Cannot break that up, cannot break that up, can't go through the Kropke dot, so this has to go up. Okay. So it cannot go that way. This has 3 slither link edges, this has 2. I don't know if this connects that way. This has 2, so this is already done. This has to have one of these cells be a slither link, at least. Can it ever be one without the other is the question. If it goes this way, so say you have a slither link here, it cannot go back here, so it would have to go here. So that means this is always a slither link. So it cannot go here. Obviously none of these are valid. This is not valid, neither are these. This is not valid, obviously. It can't go in here because it would get stuck. can't go here because it would get stuck. Hmm. What else do we have? Either one of these two has to have a boundary between it. And the other one does not. So it goes either this and then there. That's interesting. Or it goes this way and then there. Oh, okay, well, we know. This 3 eliminates 3 here, so this is 9. This cannot be 9. This 3 and 6 adds up to 9, so this is the border there, which means this has to go there. So that connects to there. This is not a boundary. This is not a boundary. This goes one of these two ways. We're not sure which. This cannot close off this way, because then this would still have 2 cells. So this is not a slither link. It has to go up. So this has 1. This 6 eliminates 6 here, so this is 3, which makes this 6. This 7 eliminates 7 here, so it's 9 and 7. This 3 cannot have 3 slither link around it, so this cannot go this way. Therefore, it must continue connect to that. Therefore, these cannot connect. So if it goes there, that would necessarily connect, and this would form a closed loop by itself with the other loop not being part of it. So it cannot go this way. It has to go up. This segment cannot connect to here because that would close the loop. So it cannot go this way, so it must go up. It must connect to here. That means this must go up here. It cannot connect to here, so it must go up here. What does this connect to? Can't connect to here because this would branch. This cannot connect to anything here, so it must go around. So this must connect this way. This has to connect to here. I guess it could be go up necessarily, so that's not necessarily true. It can't go here. So then this must connect to here. So it must connect that way. This could connect that way. We don't know. We have 2. This doesn't have any. This does have 2. This cannot connect at all because that would branch then. So this cannot, this only has 1 slither link around it, so it doesn't have a circle. So this is 8, this is 1, which forces this to be 1 and that to be 8. So either this slither link goes up here and around, or it connects here. We're not sure which. This must connect to here. So this has to go up. Obviously, it can't connect this way. It could connect here, it could go around. That's fine. Ah, if it just connected to here, this would be one Slitherlink cell around. Well, technically it could go down here. So that actually could work if as long as this goes that way weirdly. So that's no good. Ah. Okay. This cannot connect because they would branch. And if it went this way, if this went this way, this would have a 2 Slitherlinks around it. So that's not possible. So this cannot go this way. So it cannot connect all the way around here. So these are all not good. Therefore, this must go down. So this must go down that way, which means this has to go out that way. This has to go back out that way. Can't go down because that would form a loop by itself. So it must go here, which means it connects to here. This has to go down that way. It's 2. It can't close off, so it must go here. If we tried to go down here, this connects to this, and then this forms its own loop, which is not allowed. So it cannot go down. It has to go left. It has to connect to here somehow, so it has to go up. So then that's connected. This can't go up because that would branch, so this must go that way. And this could go around. This cannot go here, so it must go around here. It cannot go here because then that would form its own loop. So it has to go around here, and then this must connect there. Okay. This 3 eliminates 3 here, so this is 6, this is 3, this is 6 consecutive with 5. That makes this 4. 6 eliminates 6 here, so this is 8 and 6. This 4 eliminates 4 here, so it's 5. And this must be 4. And that's the solution. Pretty cool, actually. I've never really done Slitherlinks before, so this was actually a very interesting exercise for me. Right, so this one, let's check all the... Okay, well, there's a lot of black X's, which I'd like to remove. This was just only helpful for seeing what could and couldn't be Slitherlinks, essentially. So we're just checking now. Ugh. Okay, I'll get there eventually. Okay, the circles. Actually, just check all the 1, 2s, and 3s, because 4s can never be completely surrounded. 3 does not have 3 Slitherlinks around it. This 2 does have only 2 Slitherlinks. This 1 has 2 Slitherlinks around it. This 1 has 3. This 2 has 2. This 3 has 1. This 1 has 3 Slitherlinks. This 2 has 1. This 3 has 1. This 1 has 1 Slitherlink around it. This 2 has 0. This 3 has 2. This 1 has 1 Slitherlink. This 2 has 1. This 3 has 2. This 1 has 3 Slitherlinks around it. 3 has 2. This 2 has 2. This 1 has 2 Slitherlinks around it. This 2 has 1. And this 3 has 0. This 1 has 1 Slitherlink around it. This 2 has 1. This 3 has 2. And this 1 has 2 Slitherlinks. This 2 has 3. And this 3 has 3. And that shows that works. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.